Hello guys, welcome back to the channel. I know it's been a long time since I have given any contest and posted the solution because I was pretty occupied with my job and a lot of work. As you all have seen that I've recently switched. But yeah, from now on I'll try to be more consistent with the contest and will able to provide you the solution as soon as possible. So yeah, so today I was giving this Codeforces Round F2. So till now I solved ABC and will give you the solution for ABC, and if by the end of the contest I'm able to solve D, we'll add that also in the video. So yeah, let's discuss how the problems are. So a problem is saying that Alice and Bob are given two binary string s and s of length n, and they should contain at least this, and each can perform one operation. First, Alice has zero occurrence. Okay, choose an occurrence 0 and delete it, and similarly the Bob. Okay, now so the problem statement is saying that currently we have a string where we have something like 0 1 0 0 0 1 1, something like this, right? Now Alice can do what Alice can do is Alice can take any occurrence of 0 and delete it, and this could be done only once. And similarly for Bob, it could pick any occurrence of 1 and delete it, and it also can happen only once. Now we need to give the final string, what could be the possible string, and Alice wanted it to be lexicographically higher and Bob wants to be lexicographically lower. I know most of you know that what does the lexicographic order means. So lexicographic is something like it a sorted order kind of a thing, like the most sorted order kind of a thing, you can understand it, right? So you know lexicographically order, what do we mean by lexicographically greater and lexicographically smallest, like a kind of an ascending you can understand as a, like in a simpler terms. So now if Alice wants the string to be lexicographically higher, then it would have to delete the first occurrence of 0, right? The first occurrence of 0 which has a rightmost 1 to it, right? If she would have deleted some occurrence of 0 which would have a 1 just right to it, then deletion of this would actually increase the value of the string, right? Similarly for Bob, if Bob wants the string to be lexicographically smaller, right, then what would have it done is it would have deleted the first occurrence of 1 which would have a 0 with it, right? Then it would have deleted this one, and the 0 would have decreased in the value of the string, right? Now if both have would been 1 1 or 0 0, then deletion of any would not be a problem, right? So both of them would be deleting the first occurrence of 0 and the first occurrence of 1, so rest of the remaining would be our string. So this is how the first problem was. It was very easy, right? So yeah, let's jump into the problem B, right? So let's discuss what the problem B is saying. Okay, so problem B is saying that we are given two arrays A and B of length n and m, and respectively n and n plus m are all distinct. Okay, and we could perform the following operations on A, pick two elements x and y, and okay, delete. Okay, perfect. So I thought like problem statement is not that tough, and most of you would have understood what the problem statement is saying. So what they are saying is that we are given with an array. This is an array A, and we are given with some array B, right? This is of length n and this is of length m, right? And we have some of these numbers. We pick this number, this would represent as x and this would represent as y. Then between x and y we will pick some number z, right? And we could delete this x and y and put z in place in the array A. Now what we have to tell is we need to tell that whether after any rearrangement of A would it be equal to B, right? Okay, so now if we see this problem, this is actually a very brute, I would say, like a very greedy level of solution, right? So if you would have thought this problem correctly, okay, first of all, if let's deduce one particular thing, right? Let's deduce this, that if n is less than 2m, the answer would always be no, right? This would always be no, right? Because for every element in B, it should have at least two elements in A, right, to make this thing possible, right? So if n is less than 2m, the answer would always be no. Now you also need to understand one thing over here, is that for every b of j, right, there should be some a of i which is less than b of j, and some a of k which is greater than b of j, right? So this could be taken as the left bound or lower bound of something, and this could be understood as the upper bound. Yeah. So for every b of j, you would have to understand this thing, that there would be two elements in a of I and a of k, right? This a of I and a of k would be specifically for b of j, right? So if they are specific to for b of j, then can I say that there should be m pairs of lower bound and upper bound for a particular b of j, right? So there would be m pairs for that. And if we like give a brute logic, if I sort a and I'll sort b as well, let's do a sort for a and b. Now can I say the first m letters of a should be less than first m letters of b, like b would always be m. So the first m letters of a should be less than this, then only they would work as a lower bound for every element, and the last m characters of a should be greater than the m elements of b, right? Then only I would be able to perfectly say that there would always be a number between, if I pick any number a of I and a of k over here, I would be able to find the some number of b here, right? So this is how you would be solving this problem, right? It's also a very easy problem, just you need to deduce this particular logic. Just you need to say on what cases my answer would be no, and if you know this reason, then for rest of the cases your answer would always be yes. Okay, so now let's see the C problem. C problem was actually a bit easy, not easy problem, it's actually a good problem. You just need to visualize some things. Okay, so let's see the C problem, what the C problem is saying. Okay, so if you read the C problem carefully, what the problem is saying, that you are given with an array of 2L, okay, and okay, so what they are saying is you are given with some array A, right? This has some duplicate elements. Duplicate element is that from 0 to n, each number is existing twice for this 2n length of an array, right? From 1 to n, sorry, not 0, it should be from 1 to n. Yeah, from 1 to n, every element is occurring twice. Then what you are doing is, if you are picking any element x, let's suppose 1 is here and 1 is here, and there are some more elements to it. If I pick any element x is equals to 1, then this particular range I would be considering, right? I would be considering this particular range, and for this particular range my score would increase by this, sorry, r minus l plus 1, and all those elements between this range would be deleted. Then my array would become something like, if this is 2, 2, 3, 3, then my array would become 2, 2, 3 and 3. Then I would pick this range and then would pick this range, then my score would add up. So this is how you are like, this is what the problem statement is saying, and the problem statement is saying that you need to find the maximum possible score. Now while reading this problem, aren't we getting any DP kind of a smell, that because I'm having some kind of options for every element I choose, I'm having options that if I pick this particular range, right, then I'm left with this range and the range on the left of this. Then I need to do some operations again on the smaller subset, right, to find the score for the rest of the elements, right? So we can think of something like DP over here, right? Now let's see how can we apply DP over here. Okay, so if I say, let me define the DP state. If you have followed my previous videos, for every DP solution, if you want to go for a DP solution, you need to first define the state of the DP. So if we define the DP state, or DP of I is maximum score possible using first I elements, like using first I elements, right? If I define dp as this, right, then I'm having two options for each element. For this ith, I'm having two options, right? Let's discuss the first option. So the first option says, if this number could be used, the aith number or the ith number, this ai can be used as a single number, right? This could be used as a single number as well. Single number means, let's suppose this 2, let's suppose the 2 is here and the 1 was here, right? Then this particular range would have been exhausted. Then the array would have become like 2, 3 and 3. Then this 2 would work as a single number. For here the L is equals to R and it would work as 1, right? In that particular case, if this particular number is working as a single case, then can I say dp of I would be equal to dp of I minus 1. The score we have till the I minus 1th, plus this number is acting as a standalone. So this could be the dp of I, right? Now the second approach is that it could be working as a, like it would be falling in some kind of a range, right? Some range between ij range, right? Now if the current element is a of I, right? If this current element has been appeared at some jth index before I, let's suppose we are dealing in this particular range and we are talking about this particular I, and this a of I has been spotted somewhere here, this jth index, right? Then can I say dp of I would be equal to maximum of dp of I, like the sum that I could get here, plus dp of j minus 1, that the sum that I would have taken till here, plus the range of this, right? Plus the range of this would be I minus j plus 1 square, right? I can write this, right? I could define this as the next transition. So this would, like these are my two transitions for dp of I. dp of I can be this or dp of I can be this, and this would be working as a if else condition. If like this would always be there, this could always be there, but if there is a previous occurrence, then we could use this state as well, right? And so then you will finally print the dp of 2n, which would give you the answer, because you are using the first 2n elements, which would give you the final answer. And this is how you will be solving this problem. Yeah guys, so if you feel this video helpful, do share, like, subscribe the channel, and also let me know in the comment section that what concepts you want me to cover as a part of your coding journey, and how was your switch preparation going on, and what inputs do you need from me, and what topics you want me that you could explain us, or I could make a video on this, because I was thinking of to make a DSA series, like not just like a general DSA series that there is for everything. Like I'm trying to make a DSA series where I would be solving the problems and posting the problem solutions for you. So if you want something like that, just let me know in the comment section. And I was also thinking of to make a CSCS proper playlist for you guys, because that's actually a very good problem set if you want to solve for the solutions. Yeah guys, so see you in the next contest discussion, and if you want any discussions, just let me know in the comment section. Feel free to ask any questions. Yeah, thank you everyone.